Okay. All right. A couple of things I wanted to say about this. Again, acceleration is, change in velocity over change in time. Okay, we'll come back to that. But I want to look at the velocity here, because what the velocity tells us, or this graph, it's horizontal. But if you remember the area under this curve right here, that area tells you your change in your position. So the area, keep hitting this, I'm still getting used to this pen here. The area tells you your displacement. It does not tell you where you started from. It does not tell you your position. Okay, so for you calculus folks here, this is your integral, but when you integrate this, you have a integration constant. It just doesn't tell you your starting point. So change in position doesn't tell you your starting point. Okay, all right. So now let's look at something that's actually a velocity that's actually changing. Now, actually, we'll go on and do what I was originally planning on anyway. Let's go to here. All right. So what I've done is I've got two identical sets of your axes, and these are going to be the same thing. Okay, for the same quantities. All right. So this is going to be position. I keep forgetting to do that. All right. So this is going to be position and time. Okay, position and time. All right, this is going to be for velocity and time, and this is going to be for acceleration and time. Okay, so let me just finish filling that in. Time, acceleration, and time. Okay, now for my position, let's say that I start here. I'm going to move away. We'll move to the right pretty sharply. I'm going to stop, and then I'm going to come back very, very, very quickly. Let's say I come straight down, almost straight down. Ah, that's horrible. All right, let's try that again. Let's do something like that. All right, okay. So first of all, let's look at our slopes here for a minute. Moving away, that's a positive velocity. Horizontal, I'm not moving, I'm standing still, and this is a negative velocity. So if I had to sketch, and I'm putting these little lines here trying to line up the times, it's not perfect. So I don't care where I started. Let's say that this, now I don't have numbers here, this is a sketch. Let's say I'm going back, I'm moving away to the right at this, and again, this means I'm moving to the right. Alright, so moving to the right, I get to this segment right here, right there, and I'm going to come to a stop. Alright, and I'm not going to move. Alright, then I get here, and I'm coming back faster, so I'm going to have a negative velocity, and I'm going to come down. Let's say I come down about right here. It's got it, the horizontal line, it's going to have to be further away from the axis. Okay, and I think that's about the right spot right there. Okay, so I'll put a dotted line right here. Okay, now again, what we said in just a minute ago, this is your displacement, and it's positive. This is a negative displacement. Okay, and notice that this area looks to be bigger than this area right here. Okay, so this is smaller, this is bigger, and sure enough, you ended up closer to the origin, all right, closer to this part right here than where you started. Okay, so you would expect that to be true. My acceleration, change in velocity. Now, we're not going to worry about this instantaneous velocity right here. We're not going to worry about this little area right here. We're assuming it happens instantaneously. We know it can't do that in the real world. We understand that. But ignoring these parts, basically my acceleration is 0. Alright? My acceleration is 0. Alright, now let's look at something else. Let's look at something that's actually changing. Okay. So let's assume that we're going to start again here, and we're going to have a curve line. Okay. Well, we have a curve line. Now we're going to assume that the acceleration is constant. It doesn't have to be. Okay. Now we're going to assume that these are constant acceleration. All right. I'm going to have to go back and do something without constant acceleration, but this is a review. So you get this sort of curved line here. And when you get a curved line like that, and again, if it's constant acceleration, you have to be told that. Okay. Free fall is also constant acceleration. You're going to, the velocity will be increasing at a steady rate. Constant acceleration means that your velocity is going to be a slanty line, okay, versus over here this was a constant, okay. And let's say that you got to here and something happened and it turned around and did this, okay. Well then, assuming, and I don't know what the acceleration is, but you would obviously at that point have something that that changed, okay. So this would be a positive slope. This would be a negative slope, okay. And your acceleration is again the change in velocity. So since the slope is constant, your acceleration would be constant. And then when it changed to be to a negative, right here, change to be a negative, then your acceleration would be a negative, as well. Now, interestingly, the slope of this line right here, slope of that line, that tangent point tells you the velocity. Slope of your position tells your velocity. Slope of your velocity tells you your acceleration. Okay. The area under here tells you your change in position. And likewise, the area of your acceleration versus time graph, it's not a very good T, tells you your change in velocity. Okay, your change in velocity. It does not tell you how fast you're going because you don't know where you started from. You have to be given that information. Here we assume we started from 0. Okay, so this is again kinematics. This is all a review. From all this information, from all these graphs, okay, we can derive all the kinematic equations. And the next video I'm going to go over that. I'm not going to go over these here. You can find that if you want me to make a video on how they are derived, and how the kinematic equations are derived from the graphs. Email me. I'll be happy to do that for you. But again, the kinematic equations only apply for constant acceleration. That's supposed to be an A, okay? Constant acceleration only. You can only use the kinematic equations, for that. And because they're all vector equations, you better get your signs right. Your SIGN's correct as well. Okay. We'll do one. We'll make another video. Next video will just be the kinematic equations, and we'll go from there. Bye.